In video games, input lag is either the delay between the television or monitor receiving a signal and it being displayed on the screen, or the delay between pressing a button and seeing the game react. In electronic hardware development, input lag is the delay between an electronic input signal being generated and processed. In this field, the phenomena detailed below are referred to as output lag. More formally, the terms input latency and output latency are also used. Due to gamers being largely unaware of the phenomena of input lag at this low level, the terms input lag and output lag became confused over time, and the above description, where input and output lag are combined into a singular phenomenon known as input lag, has become popular. Overall, the correct terminology is clear. A delay between a physical input occurring and it being processed electronically is input lag, and a delay between an electronic output being sent and it being processed into a physically observable phenomena, is output lag. In short, input lag occurs on input devices, output lag occurs on output devices. The following are descriptions based on the colloquial use of the term, as used by gamers. Potential causes of delay from pressing a button to the game reacting. The potential causes for input lag according to the second definition are described below. Each step in the process increases input lag, however the net result may be unnoticeable if the overall input lag is low enough. Controller send signal to console equals. For wired controllers, this lag is negligible. For wireless controllers, opinions vary as to the significance of this lag. Some people claim to notice extra lag when using a wireless controller, while other people claim that the 4 to 8 milliseconds of lag is negligible. Network lag equals, since the game requires information on the location of other players, there is sometimes a delay as this information travels over the network. This occurs in games where the input signals are held for several frames before being used to render the next frame. At 25 FPS, holding 4 frames adds 160 milliseconds to the overall input lag. However, very few modern online games use this method. The view angle of every modern AAA shooter game is completely unaffected by network lag, for example. In addition, lag compensating code makes classification a complex issue. Console PC processes next frame equals, a video game console or PC will send out a new frame once it has finished performing the necessary calculations to create it. The rate at which this is achieved is measured with the frame rate. Using common 60 Hz monitor as an example, the maximum theoretical frame rate is 60 FPS, which means the minimum theoretical input lag for the overall system is 17 milliseconds. Theoretical maximum FPS is usually limited by the video monitor, since the game cannot display more frames per second than the monitor's refresh rate, of which in turn causes graphical artifacts. In situations where the CPU and/or GPU load is high, FPS can drop below the monitor's refresh rate. Display lag equals. This is the lag caused by the television or monitor. Image processing takes time and therefore adds some degree of input lag. It is generally considered that input lag of a television below 30 milliseconds is not noticeable. Discussions on gaming forums tend to agree with this value. Once the frame has been processed, the final step is the pixel response time for the pixel to display the correct color for the new frame. Typical overall response times. Testing has found that overall input lag times of approximately 200 milliseconds are distracting to the user. It also appears that 133 milliseconds is an average response time and the most sensitive games achieve response times of 67 milliseconds. References